Now we investigate the motion of two moving particles in two dimensions. There are several problems we can formulate here. First, we may want to determine if the particles collide, and for two particles to collide, they must be at the same coordinates at exactly the same time. If the particles do not collide, we may want to find their closest approach. Another possibility is that their paths will cross. Now, that is, they do not collide, but they will have exactly the same coordinates, but at different times. Okay, so let's have a look at an example of this. Two ships A and B are observed from a lighthouse at an origin O. Relative to O, their position vectors, R of A and R of B. Okay, distances are measured in kilometres here. We're not trying to trick you with units in these sort of questions. Find when and where the ships collide. Let's sketch the paths of both ships and find where the paths of each ships cross. Okay, so once again, we'll open up a calculator page and we'll define these variables. So menu, actions, define x1 of t equal to t plus 2. Define y1 of t. Often it's easier, you can just type these words in. So let's define y1 of t equal to, it was what, t squared minus 5t plus 6. And define x2 of t equal to 2t minus 4. And define y2 of t equal to t squared minus 4t. Okay, now we're going to call ship 1 R1 and ship 2 R2. So as in the last example, we'll define R1 of t equal to the matrix, and the matrix is a 1 by 2. We get that from next to the book command. So we'll scroll across till we get the 1 by 2 matrix. And in here I can type in var if I like, and I can just type in x1 of t, pressing the right arrow, and now pressing in y1 of t. Okay, it's rather easy now just to redefine for R2. Let me just press up arrow and change all the 1s simply to a 2. Okay, now we want to find when particle 1 or particle A is at the same position and coordinates as particle 2. But remember, they're measured on different time zones. So what we really want to do here is we want to go menu, algebra, solve. So I want to solve R1 of t equal to R2 of S. So S is the time frame measured for particle 2 and t is the time frame measured for particle 1. So we're going to solve that for t and S. Okay, so that gives me S equals 4, t equals 2, or S equals 6 and t equals 6. Okay, so what's going on here? Well, let's work out R1 at 2. So that means the particle is at the point x equals 4, y equals 0. Let's work out R2 at 4. And once again, we can see the particle is at that same position at x equals 4 and y equals 0. But if I work out R1 at 6 and also R2 at 6, then we see that they're both at the same coordinates. So what does this actually mean then? Well, what this means is that the particles are at the same point, that's x equals 8 and y equals 12, at the same time when t equals 6, but they also pass through the same point, and that's x equal to 4 and y equal to 0, but at different times. So, summary here. Both ships move on parabolic paths. The ships collide when t equals 6, since they're at the same point. That's the point x equals 8 and y equals 12 at this time. But their paths cross at the point x equals 4, y equals 0, since they both pass through this point but at different times. Let's see the graph then of this situation by pressing the graphs page and once again going to a parametric equation. Just press up arrow to see the graph of particle number 2. Press the tab key, go up to see the particle number 1. Now we can see that they're crossing at the same point here, and their paths are crossing at some other value. Okay, so we see that the paths are crossing at x equals 4, y equals 0, and also at this point up here as well. But at this point they collide because they're at the same time. This point their paths just cross.